Alright, so today we're covering sections 2.5, rational equation, one variable. So we're going to solve rational equations and applications of rational equations. So this is what we need 1.7 for. Rational equation. If an equation has a rational expression with variables in the denominator, then the equation is called a rational equation. To solve this type of equation, we must multiply every term on both sides of the equation by the least common multiple of the denominators. Remember that an excluded value cannot be a solution because some part of the original equation is undefined. These values appear in our proposed solution set. They are not part of the solution set and are called extraneous roots. Alright, so let's look at these. Real quick, off to the side, you see what gives you 0 in your denominator. Well, x can't be equal to 0. So write that off to the side somewhere to let you know what your restrictions are. So if you get x equals 0 back as a solution, then you say, wait a minute, I've already excluded that. So here we go over here, and we find our least common denominator or multiple of our denominators. Well, I'm going to need a 3x, I'm going to need a 16, and a 2x. So let's factor that. Well, that just factors into 3x. That just factors into 2 to the 4th power. And this is 2 times x. So I'm going to need an x and a 3. That comes there. And then I'm going to need the highest power of 2, which is 2 to the 4th. And I don't need anything from this third term. So my least common denominator becomes 2 to the 4th times 3 times x. And then we can just multiply that out. So that's going to be our least common denominator of. And that's going to be, and I'll just leave it as, I'll write it down. I'll just leave it as, I want to make canceling easier. But we can just multiply that out real quick and say that's going to be 16 times 3. Which is going to be 48x. Use your calculator if you need to. And then, so what happens here, instead of multiplying top and bottom by 48x, I just need to multiply each side by 48x to get rid of all my denominators. All right, so now that I do that, I'm going to get 2 times 48. I don't want to cancel the 2 yet. And like I said, sometimes it might be easier to leave it as prime factorization so you can see those 3's canceled. Maybe that's easier for you. It's a personal call. And then we say that equals 5 over 5 times 48x. Over 2x. So now that I have this, so I'm going to have 2 times 48x. I've just distributed my 48x to all my numerators. So 2 times 48x over 3x, 5 minus 5 times 48x over 16 minus 5 times 48x over 2x. So now I'm going to go through and cancel. And if I did it right, all my denominators should cancel. So we're going to cancel our x's here, our 3's here, so that gives us a 16. And then we're going to cancel our 16's here, which gives us a 3. And that x stays. And then right here, we're going to cancel our x's, and we're going to cancel a 2 from here. So 2 into 48 would give us 24, which is 8 times 3. And then we go and write our simplified expressions. So all our denominators canceled out, which is what we want. So I'm going to have 2 times 16, which is going to be 32. X. No x. Cancel that x, remember. Minus 5 times, so it's going to be 15x, and this is going to be 4 times 24, which is, 5 times 24, excuse me, 5 times 24, which is going to be 100, so it's 120. So now I need to move all my constants on one side, all my variables on the other, so I'm going to have negative 15x equals 120 minus 32. And sometimes it's good to have a calculator out. Make sure you don't make a lot of mistakes, especially when we're recording video. And so that's going to be 120 minus 32. And so you're going to have 88, and then you're going to have negative 15x equals 88. And so that means x equals 88 over negative 15. And you always display your answers as fractions. You don't turn them into decimals unless they ask you to round off, or I ask you to round off. But you just leave it as a fraction, because if you round off and it wanted a fraction as an answer, it's just going to say not in the correct form. It may count it incorrect in Hawks as a total. So leave everything in fractions and radicals unless told to put in decimal form. Oh, one thing we didn't check. Since this is our answer, we had to check it against our restrictions, and we could see that, you know, the answer wasn't 0. And you could always plug it into your calculator, and it should work out if you plug in 88 over negative 15 for your x. Do the same thing here. We're going to go off to the side and say x cannot be equal to 0 or negative 2, because that would be undefined. Those solutions are not allowed in that equation. If they happen to be a solution, those numbers aren't allowed. My LCD, I need an x. I need an x plus 2. Remember that x plus 2 is a factor in itself, and then a 5, which just makes this is going to be the least common denominator is going to be equal to, I'm going to need all of them, which is going to be 5x times x plus 2. Once again, I don't want to multiply that out because I'm going to cancel those factors here in a moment. So I'm going to multiply the left-hand side, 1 over x plus 1 over x plus 2 equals 1 over 5. I'm going to multiply that by the least common denominator, 5x times x plus 2 quantity. This side by the same thing, the right side, 5x times x plus 2 quantity. And then when I distribute this across, I'm going to get 5x, it's x plus 2 all over x plus, excuse me, 5x times x plus 2 all over x plus 2. And that's going to equal 5x times x plus 2 all over 5. And we go through and we cancel our denominators. And once again, if we pick the correct least common denominator, those can cancel. So in the first terms, the x's cancel. Second term, the x plus 2's cancel. And in the last term, or the right-hand term, my 5's cancel. And so we're going to have 5 times x plus 2 plus 5x equals x squared plus 2x. So that's going to give us a 5x plus 10 plus 5x equals 2x, or sorry, x squared plus 2x. And so we're going to get a 10x plus 5, plus 10, excuse me. 10x combined to give me 10x plus 10 equals x squared plus 2x. So I'm going to get everything on the right-hand side. I'm going to move everything to the right-hand side just so I don't have to move the x squared. So I'm going to get 0 equals x squared. And then when I subtract 10x from both sides, I get minus 8x. And this is going to be minus 10 because those came from the other side. So looking at this, I need factors. I need factors of, let's see. I need factors of negative 10 that whose difference is negative 8. Well, if I go over here and I say 1 and 10, 2 and 5, well, the difference between 1 and 10 is 9. The difference between 2 and 5 is 3. So neither of those work. I need an 8. Always double check your math. When you move the negative 10, you subtract the 10x from both sides. 10x from both sides. You do get a negative 8x. So that in case, we're going to have to use the quadratic formula. So if we have to use the quadratic formula, it almost guarantees you that it's not going to be an integer. And so I'm pretty safe to say that my solutions are not going to be excluded. But I might want to get another sheet of paper real quick. You get and factor, or not factor, but use the quadratic formula on x squared minus 8x minus 10. And so that means a is equal to 1, b is equal to negative 8, and c is equal to negative 10. So that's going to give us what? X equals plus or negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be what? 8, positive 8 plus or minus That's going to be 64, because negative 8 squared is positive 64, minus 4 times 1 times 10, negative 10. Don't forget that negative, otherwise you'll get imaginary numbers back out. 2 times 1. And so that's going to be 8 plus or minus the square root of, and that's going to be 64 plus 40 all over 2. So that's 8 plus or minus 64. So it becomes 104 over 2. 104 actually have a perfect square in it. 104 is equal to 4 times 26. Let's say it out loud. It sounds funny. So 26. So that means that I can take that square root out. That 4 out of the square root is a 2. And that, I'm writing it off the screen. There we go. So I'm going to say we have, what do we have? We have 8 plus or minus 4 times 26 all over 2. 8 plus or minus 2 times the square root of 26 all over 2. I can factor out a 2. And you can do these in future steps. I'm just taking the most steps right now just to make sure everybody's following along. So I get 2 times 4 plus or minus the square root of 26 all over 2. 2's cancel. So I got 4 plus or minus the square root of 26. And the square root of 26 is really close to 5. So in other words, this is roughly, approximately 4 plus or minus 5-ish. So in other words, it would be 1, or it'd be negative 1, or it'd be 9, which neither one of those numbers is near these. So relatively speaking. So this is your answer. Your answer would be negative x is equal to 4 plus or minus the square root of 26. And that's your solution. And write it like that. Don't give decimal form. All right. Here's one that's even more entertaining. So very quickly, we have a denominator that needs to be factored so we can see what's going on there. So I'm going to factor it real quick. Get another sheet of paper so I can do that. Well, let me factor it on this and just continue on another sheet of paper. So I'll rewrite the problem and then just factor everything. So I need 2 factors that add and multiply to give me 6 and add to give me 5. They have the same sign. And then 3, x plus 3 and x plus 2 will do it. And then once again, usually, you know, homework doesn't try to make your life completely miserable. Contrary to popular belief, I kind of knew those were going to be the factors because I had an x plus 3 here in the denominator and x plus 2 here. Usually they don't want you to have all new denominators. So my least common denominator, I need an x plus 3. An x plus 3 times an x plus 2. And then I have an x plus 2. So the highest power each prime factor, well, you can get it all from the same term. Almost a pen. Right here. And so my least common denominator is x plus 3 times x plus 2. And so that's going to give me, what do I need to multiply everything by? I need to multiply this side, left-hand side of, so the original problem was x over x plus 3 plus x over x squared plus 5x plus 6 equals 2 over x plus 2. Now I'm going to multiply that by the least common denominator, which is x plus 3 times x plus 2 quantity. So I do that for both sides. And so when I distribute that across, I'm going to get x times x plus 3 times x plus 2 all over x plus 3 plus x times x plus 3 times x plus 2 all over x plus 3, x plus 2 equals 2 times x plus 3, x plus 2 over x plus 2. So I'm going to cancel out all my terms. One thing, once again, I forgot to do, like I did in the other one, is that I should have stated my restrictions first before I start canceling things, because then you might really get lost. So my restrictions, that's not a marker. Does this even work? X can't equal -3 or -2. And that's what this factors into, so we should have put that out there first. Because we're about to lose that information right here. When we cancel these out, we're going to lose that information. So I cancel all the terms in my denominators. If we pick the right least common denominator, that should be no problem. So I'm going to get what? I'm going to get an x times an x plus 2 plus x equals 2 times x plus 3. All right. Okay. Yeah. So I'm going to get x squared plus 2x plus x equals 2x plus 6. So I move everything to the left-hand side. That's where my x squared is positive. So I'm going to get x squared plus 3x. So I'm going to combine these two like terms. And then we say minus 2x minus 6 equals 0. So that's going to give us x plus x, or x squared plus x, excuse me. Minus 6 equals 0. So now I'm going to have to factor this because it's an x squared. Let's see if it factors nicely. So I need factors of 6 whose difference is positive 3. Well, positive 3 and -2 will work. So x minus 2 and x plus 3 will give me my 0 back out. So that means x minus 2 equals 0 or x plus 3 equals 0. And for that to happen, x would need to be either 2 or it would have to be -3. And then we can see up here, if we kept track of our restrictions, we would have noticed, wait, one of those numbers appeared in our restriction list right here as -3, so that's not allowed. So x minus 2 is your only answer. So a lot of times in homework, they'll leave multiple answer blanks. You can leave one of them blank, but some students don't pay attention. They put both answers in there, even though they're restrictions, and they shouldn't do that. So watch out for that. That's kind of a way they make sure you're paying attention, that you kept track of your restrictions in your domain. So yeah. So the answer was, once again, just 2. And it's a nice problem. You can actually plug 2 in this problem here and make sure it equals, and it will. It's always good to check your answer, especially if you have the time. All right. So now we have everyone's favorite word problems, application problems. So problems related to work. When faced with the problems involving work, represent what part of work is done in 1 unit of time, assuming a steady work pace. For example, if a man can dig a ditch in 3 hours, then he can do 1/3 of the work in 1 hour. Similarly, trying to not get cold. Similarly, if a fence was painted in 2 days, then 1/2 of the painting would be done in 1 day. In general, if the total work took X hours, then 1/x of the total work would be done in 1 hour. Theoretically, different parts of different jobs take different amount of times. Work's not necessarily linear, but nevertheless, let's just assume it is. Let's assume everything, same rate across the entire thing. So if Joanne were to paint her living room alone, it would take 5 hours. Her sister Lisa could do the job in 7 hours. How long would it take them working together? So this one's a nice. So when we're talking about this, we're going to make a chart here. So we're going to have. Joanne, right? And that's going to take what? So job takes her 5 hours. Lisa, the job takes her 7 hours. Working together, Joan plus Lisa would take X hours. We don't know. It wouldn't be 12 because that means they each did the job consecutively and they did it twice. So it wouldn't be 12 hours. A lot of students do that. It'd be X. I don't know how fast they get it done. That's what we need to know. So now we have job in 1 hour because we're in hours. So job done in 1 hour. So if it takes her 5 hours, she gets 1/5 of the job done every hour. Lisa gets 1/7 of the job, and 1x of the total job is done. So if we add the parts per hour, we can figure out what we need. So I'm going to say 1/5 of the work plus 1/7 of the work has to equal 1 over x of the work. So here we go off and we find our least common denominator. And we're going to need a 5. We're going to need a 7. We're going to need an x. We can just see that. They're all different. They're all unique. And so once we have that, I'm going to need to multiply everything by 35x as my least common denominator. So left-hand side, 35x. Right-hand side, 35x. And so that's going to give us 35x over 5 plus 35x over 7 equals 35x over x. So that's going to cancel my 5. So I'm going to get 7x plus 5x, because that 35 over 7 is going to give me 5x. 35x over 7 gives me 5x. And my x's cancel here. Let me show me actually canceling. So that's 7x, 5x. This is just going to be 35. So I'm going to have my linear equation now becomes 7x plus 5x equals 35. So that means that I'm going to have 12x equals 35. So in other words, if room on this side. So I would get x equals 35 over 12 hours. And then 1/12 of an hour, well, there's 60 minutes an hour, so that's about what, 5 minutes? So 1/12 of an hour is about 5 minutes. So that means that this would be 5 minutes short of 3 hours. So this would be about 2 hours and 55 minutes. But usually they, like I said, they'll want fractions. Rarely they ask for. You can give decimal hours sometimes, especially if they're terminating decimals for these problems, but usually they want them in fractions. And so that's how fast. Now, some students may be very savvy and realize, wait, if I add up 7 and 5, I get 12, and if I multiply them together, I get 35, and the answer is 35 over 12. That only works when they don't have any least common denominators. They don't have any common factors in any of your numbers. But that's not going to work all the time. So please do it this way. Sometimes nice numbers give you nice answers back out, but if you don't do the process, you're going to get lost pretty quickly. Justin recently drove to visit his parents who live 420 miles away. On his way there, his average speed was 24 miles per hour faster than on his way home. He ran into some bad weather. If Justin spent a total of 12 hours driving, find the two rates in miles per hour. Round your answer to 2 decimal places if needed. So looking at this, if we let R be the average speed on his way home, so on his way home, he was what? He's 24 miles per hour on his way home. So his average speed be the average speed on his way home, and 20 be on his way to the parents. So on his way there, he's 20 miles per hour faster than on his way home. So on his way home is the slower speed. Going there was faster. So if you spent total 12 hours, find the two rates in miles per hour. So what we want to do is say, well, distance equals rate distance equals rate times time. So time, which is time there, time back, we're adding those together to get 12. Time is equal to distance over rate. So we want time to parents plus time to home to equal 12. We know what D is. So D is what? D is equal to 420. So I'm going to have time to parents, which was 420 miles, divided by R plus 24. And then plus, and then we have time to, so I'm going to add that to time to home, which is 420 divided by the slower speed, because there was bad weather on his way back. And then we're going to add those together, and we're going to get the total time 12. All right. Let's work this out. So we're going to need our least common denominator here. Now, if you happen to pick the wrong time, like the slower time or the faster time, then you'd be minus. It'd be R minus 24. You get the same thing. But yeah, just be careful that you make sure that you're adding when you need to add. We're adding the rates together for the total time instead of like the difference or something. So I'm going to get my least common denominator to be basically R times R plus 24. There's a denominator of 1 understood here. Don't need to worry about that. And so I'm going to have R times R plus 24 times 420 R plus 24 R times R plus R times R plus R times R plus 24 bleh, times 420. Oh, I'm going to run out of room. All over R equals, well, actually, no, I just put 12 here and just multiply by this common denominator. We can do that. So what are we going to get here? Our R plus 24s cancel in the first term. And then we have our R's cancel in the second term. And then nothing cancels in our last term. So we're going to get the following. We're going to get 420R plus R plus 24 times 420 equals 12 times, and the reason why I'm leaving 12 out is I'm pretty sure 12 divides into 420. Let's see if that happens. 420 divided by 12. That's 35. So let's divide everything by 12 instead of multiplying that out. I'm going to say that's R squared plus 24R. So I'm going to divide everything by 12. Makes life a little bit easier. So I'm going to get 35R plus 24 times 35 equals, and this is going to be R squared plus 24R. So do a little bit of multiplication here. So I'm going to have 35R plus 35R plus 35 times 24 is going to be a large number. $840. R squared plus 24R. And so now move that all to one side. So I'm going to say, well, this becomes 70R. So I'm going to move that all to one side, and this becomes 0 equals R squared plus 24R minus 70R plus, or actually minus 840. And so that's going to be R, and we have 70 minus, what is that, 24? So 46. So that's minus 46 R minus 840. These numbers are kind of big because it deals with driving distances. A lot of these problems are smaller, especially when they don't deal with driving distances. So now I need to factor this, and I think it factors nicely because they want to give you nice numbers back out, but it may not in your example. So what are we going to have here? We're going to have an r times r. So I need factors of 840 that will give me a difference of 46. So, just starting off real quick, 10 and 4, that doesn't seem to work. What about 20 and that's it in half? So I'm looking for their difference to be 100. So thinking about it, okay. So for some reason I was drawing a blank there. I kept wanting to divide it by 70 and trying to factor by grouping up here in my head, and I was like, that's not working. But what it is, it's actually I skipped the factor 14 right here. That's what I wanted. And 14 and 60. And the difference between 14 and 60 is 46. So I'm going to have r, and then I'm going to have plus 14 because I want the number to be negative, and r minus 60. And so that's going to be what? So that means r equals 14, negative 14, or r equals 60. 60 seems like a pretty good hop speed. So you're not going to go negative because that doesn't make sense. So that's out. So you're only going to want the positive answer. And so over here, you go back to the original problem. Hopefully everything I just did was on camera. I'm going to go back to the original problem. I want to say I have 60 miles on the way there, and then 60 plus 24 miles on the way back, which seems a little bit fast. Maybe seems a little fast, but nevertheless, it could be. Maybe he speeds. So those are our two speeds. On his way home with 60 and 8. And if you want to make sure it makes sense, you could always take 420, divide that by 60 plus 420, and divide that by 84. It's supposed to be plus, right? 84, and that'll give you what? That'll give you 420 divided by 60 plus 420 divided by 84 gives you 12. So 12 hours. So that checks out. So always good. And I want both speeds, so make sure you get both speeds. And it's a reasonable answer. A little fast, reasonable though. Now, if you got like something like 10 miles an hour in a car, I'd be like, you might want to check that. If you got something like 1,000 miles, you definitely want to check that. Make sure you factor it correctly. So any extreme answers, you definitely want to double check that your answer makes sense in your equation. But other than that, you all have a great day.